Problem number 3, I'll read. Calculate the moment of inertia and the radius of gyration of grinding stone which is used for the grinding machine. It is in the form of a disc, 90 cm diameter, 10 mm thickness. So let us draw grinding stone. Grinding stone is in the form of a circular disc as shown here. The dimensions are given, its diameter is given 90 centimeters, its thickness given, so this is the thickness of the grinding stone, it is given as 10 centimeters, 10 centimeter thickness with respect to its axis of rotation. Now this is the center of this grinding stone, that is centroidal axis. So with respect to this axis it will be rotating. With respect to this axis, this grinding stone is rotating. So stone density is given. So let us solve this problem. First let us calculate volume of the grinding wheel. This is grinding stone wheel. Volume of wheel V equal to pi by 4 d square into thickness, that is pi by 4, its diameter given 90 multiplied by the thickness 10 centimeters, it is equal to 63617.25 cubic centimeters. Now let us calculate mass. We know mass equal to density into volume. So its density is given here, that is 0.0026 into its volume 63617.5. Its value is 165.4 kgs. Now moment of inertia of a grinding stone about its axis. About its axis. We know formula for the circular disc because it is in the form of a circular disc. Formula is mr square by 2. So mass is 165.4 kgs into its radius. So diameter is 90. So radius is 45, half of this, divided by 2. Diameter 90 centimeters. So radius is 45. So if you convert this into meters, we get 0.45 meters. We can also calculate in terms of meter. Then it will be 0.45 meters. Now the total value of this moment of inertia is 16.75 kg meter square. So this is the answer for the moment of inertia. Now let us calculate radius of gyration. We know formula for the radius of gyration, that is k equal to I by m under. Now we know moment of inertia I, that is 16.75 divided by its mass. So calculated, that is 165.4 under root. Its value we are getting as 0.3182 meters, means it is 31.82 centimeters. So this is the second answer. So he is asking to calculate moment of inertia of the disc, that is I equal to mr square by 2. We have calculated. The second bit is he is asking to calculate radius of gyration k. So k equal to under I by m. We are getting this. So we got two answers. With this problem is complete.